All right, let's tackle a topic that, can make even experienced network folks get a little tense: subnetting. But what if I told you there's a way to get this down, a really simple way that completely avoids all the painful binary math? Well, there is, and we're going to walk through it right now. Yes, subnetting calculations. You can almost feel the collective groan, can't you? It's that chapter in the networking book, that section on the certification exam that everyone dreads. It's got this reputation for being incredibly complex and, let's be real, kind of scary. So, I want to be super clear about this from the get-go. We are skipping the usual math torture session. Seriously, we're not going to be converting numbers to binary or messing with complicated formulas. The whole point here is to make this make sense, to give you confidence, not a headache. So, what's the secret sauce? It all comes down to one single concept: block sizes. This idea is the key that unlocks the whole thing. Instead of calculating, we're going to start thinking in these simple, predictable chunks of addresses. It's really more about spotting a pattern than it is about doing heavy arithmetic. This entire method, the whole thing, is built on just these 4 simple rules. That's it. If you can get these 4 ideas down, you are pretty much halfway there. We're going to use these every single time, and you'll see how they make the process totally repeatable. And here is the first little piece of magic. When someone says, hey, I need 25 addresses, you don't have to do any math. You just look at this list, these powers of 2, and you pick the next number up that's big enough. You need 25? You pick 32. You need 50? You grab 64. It's honestly that straightforward. Okay, now this right here, this is your ultimate cheat sheet. This one little table is the engine that makes this whole thing work. It connects the block size you just picked to the CIDR notation you need, that slash number, like /27. See that last column? Those are our block sizes. You just find your block size, look to the left, and bam, you instantly know your subnet mask. This is the whole trick. All right, enough theory. Let's actually put this into practice and see how easy it is. We're going to take a really common request and solve it step by step using only our rules and that awesome little table. Okay, here's our first problem to solve. We're starting with a basic network, 192.168.1.0/24, and one of the departments tells us, hey, we need 25 IP addresses for all our new computers. We're going to follow these exact 4 steps. It's like a recipe. First, pick the block size. Second, use the cheat sheet to find the right CIDR. Third, figure out our increment, which, spoiler, is just the block size again. And finally, we just fill in the blanks on our chart. Let's do it. Step 1, choose the block size. Okay, we need 25 addresses. Looking at our list of power of 2 numbers, what's the next size up that can fit 25? It's 32. So our block size is 32. Done. Simple as that. And here is the final result. Look at how this all comes together. Remember step 2? Our cheat sheet told us a block size of 32 means we use a /27 subnet mask. Now for the really cool part, that block size, 32, is also our increment. Look at the network addresses. They go up by 32 every single time. 0, then 32, then 64, 96. You see the pattern? And the broadcast address for any subnet is always just one number less than where the next one starts. It's so clean and simple, right? Okay, let's run through one more just to really make sure this concept is locked in. It's a different scenario, a different network address, but we are going to use the exact same process. This time, the request is for 50 addresses. So we need 50 addresses. What's the next power of 2 block size? That's right, 64. We go back to our master table, and it tells us a block of 64 lines up with a /26 mask. And that means our networks are going to jump by 64 each time. And here's what it looks like: 10.0.0.0, then 10.0.0.64, then 128, and so on. It's the exact same logic, we just swapped out the block size. Now that you see how this method works, let's quickly talk about a couple of common things that can trip people up. If you know what to watch out for, you'll get the right answer every single time. Okay, this is absolutely crucial. You have to understand the difference between total addresses and usable hosts. A block size of 32 gives you 32 total addresses, that's true. But you can only actually assign 30 of them to your devices, like PCs or phones. Why? Because the very first address is always reserved as the network ID, and the very last one is reserved for the broadcast. So you always subtract 2 to find out how many devices you can actually use. And here are 2 other quick things to keep in mind. First, always round up to the next block size. For instance, if you need 31 usable IPs, a block size of 32 is not big enough, because that only gives you 30 usable IPs. you'd have to jump all the way up to the next block size, which is 64. And second, just remember that easy trick for finding the broadcast address. It's always just one less than the starting address of the very next subnet. Okay, let's pull all of this together. Let's recap what is now your new stress-free subnetting process. This is your go-to toolkit from now on. This is it, right here. 5 simple, repeatable steps. 1. Figure out how many addresses you need. 2. Pick the next power of 2 block size from the list. 3. Use that awesome cheat sheet table to get the CIDR number. 4. List out your subnets by just adding your block size over and over. And 5. Fill in the details for the network, hosts, and broadcast. That's the whole game. And that's really all there is to it. The moment you start thinking in terms of block sizes, subnetting stops being the scary math problem and turns into a simple, pattern-based puzzle. No stress, no confusion, just clear, logical steps to the right answer. So, you've totally got the what and the how of creating subnets down. But that opens up the next big question, which is, why? Now that you know how to carve up a big network into these smaller, more efficient pieces, how do routers actually use that information to make lightning-fast decisions and send data across the world? That's where the skill really comes to life.